Hello everyone. Today we are going to analyze this frame using slope deflection method. Before analyzing, let us see the frame one time. In this frame, there are two columns, column AB and column CD. Also, there is a beam BC. In the column AB, there is uniformly distributed load 12 kN per meter acting for the full span. In the beam BC, there is a point load 20 kN acting in the center. In the column CD, there is a point load 27 kN acting at 1 meter from the point D. The moment of inertia for the span AB is I, for the span BC is 3I, and for the span CD is 1.5I. Length of the column AB is 4 meter. Length of the beam BC is 4 meter. Length of the column CD is 3 meter. In the points A and D, there are fixed supports. This frame is a sway type frame because the columns AB and CD are having different lengths. Now let us find the kinematic indeterminacy of the frame. In the joint B, there is slope theta B. In the joint C also, there is slope theta C. We know that this frame is subjected to sway. Let us assume that the sway occurs towards the right side. So the kinematic indeterminacy of the frame is 3. They are theta B, theta C, and the sway delta. Now let us find the fixed end moments in the column AB. In the column AB, there is UDL 12 kN per meter acting for the full span. The formulas for the fixed end moments are minus WL square upon 12 and positive WL square upon 12. Here W is 12, L is 4. When we apply these values in the formulas, we are getting M of AB and M of BA. Now let us find the fixed end moments in the beam BC. In the beam BC, there is a point load acting in the center. The formulas for the fixed end moments are minus WL upon 8 and positive WL upon 8. Here W is 20, L is 4. When we apply the values in the formulas, we are getting M of BC and M of CB. Now let us find the fixed end moments in the column CD. In the column CD, there is an eccentric point load 27 kN. The formulas for the fixed end moments are minus WAB square upon L square and positive WA square B upon L square. Here W is 27, A is 2, B is 1. When we apply the values in the formulas, we are getting M of CD and M of DC. Now let us make the slope deflection equations. First, let us make them in the column AB. Since the column AB is subjected to sway, we have to add the moments due to sway with the slope deflection equations. Since the sway occurs towards the right side, the moment due to sway will be negative. In the equations, let us apply the fixed end moments. Length of the column CD is 4 meter. Let us apply that. In the point A, there is a fixed support. In the fixed support, there will be no slope. So theta A will be 0. The moment due to sway will be same for both of the equations. So we can simply apply this value here. No need to calculate again for MBA. Finally, in the column AB, we have made two equations. Now let us make the slope deflection equations in the beam BC. In the equations, let us apply the fixed end moments. Length of BC is 4 meter. Let us apply that. The moment of inertia for BC is 3I. So instead of I, we have to apply 3I. Finally, in the beam BC, we have made two equations. Now let us make the slope deflection equations in the column CD. Since the column CD is subjected to sway, we have to add the moments due to sway with the equations. In the equations, let us apply the fixed end moments. Length of column CD is 3 meter. Let us apply that. The moment of inertia for CD is 1.5I. So instead of I, we have to apply 1.5I. In the point D, there is a fixed support. In the fixed support, there will be no slope. So theta D will be 0. Finally, in the column CD, we have made two equations. Now let us make the joint equilibrium equations. In the joint B, there are two moments, MBC and MBA. When we add both of them, it will be 0. We have already made the slope deflection equations for MBA and MBC. Let us apply them. Then let us add them and keep the numerical on the right side. Let us keep this equation as number 7. Also, in the joint C, there are two moments, MCB and MCD. When we add both of them, it will be 0. We have made the slope deflection equations for MCB and MCD. Let us apply them and then add them. Let us keep the numerical on the right side. Let us keep this equation as number 8. In this analysis, there are three unknowns, EA theta B, EA theta C, and EA delta. So we need one more equation. Let us see how to make that. Let us take the column AB and find the horizontal reaction HA. When we do that, we have to always assume that MAB and MBA are acting in the clockwise direction. Also, we have to assume HA is acting towards the right side. Let us take movement about to B. In this case, I am moving towards right hand side. Clockwise will be positive and anti-clockwise will be negative. HA is acting in the anti-clockwise direction and the distance is 4. So minus 4 HA. The movements are acting in the clockwise direction. So both of them are positive. The UDL is acting in the anti-clockwise direction. So it will be negative. When the UDL comes, we have to multiply with the distance and a distance by 2. Finally, for HA, we are getting this. Then we can divide minus 96 by 4. We will get minus 24. Now let us take the column CD and find HD. Here also we have to keep the moments MCD and MDC in the clockwise direction. Let us take movement about C and find HD. In this case, I am moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. HD is acting in the anti-clockwise direction, so it will be positive, and the distance is 3 meter, so 3 HD. The movements are acting in the clockwise direction, so both of them will be negative. The point load is acting in the clockwise direction, so it will be negative, and the distance is 2 meter, so 27 into 2. Finally, for HD, we will get these. Let us divide 54 by 3. When we do that, we will get 18. Now, in the frame, let us apply the rule sigma h is equal to 0. HA and HD are acting towards the right side, so both of them will be positive. The UDL is also acting towards the right side, so it is also positive. For the UDL, we have to multiply with the distance. The point load is acting towards the left side, so it will be negative. For HA and HD, let us apply these expressions. Then let us add these four values. Then let us take it on the right side. Then let us take LCM. 4 into 3, we will get 12. These two terms we have to multiply with 3, and these two terms we have to multiply with 4. 12 into 15, we will get 180. Let us apply the expressions of MAB, MBA, MCD and MDC from the slope deflection equations. Then let us multiply this equation with 3, this equation with 3, this equation with 4, and this equation with 4. When we do that, we will get these. Now let us add these values. After adding, we will get these. We have to always keep the numerical on the right side. Let us keep this equation as number 9. Now we have three equations, the 7th one, 8th one and 9th one. We can use the calculator and solve these three equations. If you do not know how to solve three equations in the calculator, see the description below. There is a link. You can click the link and watch the video. I have used the calculator and got the values of EA theta B, EA theta C and EA delta. When we apply the values of EA theta B and EA delta in the equation number 1, we are getting MAB. When we apply the values of EA theta B and EA delta in the equation number 2, we are getting MBA. When we apply the values of EA theta B and EA theta C in the equation number 3, we are getting MBC. When we apply the values of EA theta B and EA theta C in the equation number 4, we are getting MCB. When we apply the values of EA theta C and EA delta in the equation number 5, we are getting MCD. And finally, when we apply the values of EA theta C and EA delta in the equation number 6, we are getting MDC. In this analysis, we have calculated all of the moments. In this analysis, we have calculated all of the moments. For MAB, we got a negative value. That means it is acting in the anti-clockwise direction. For MBA, we got a positive value. That means it is acting in the clockwise direction. For MBC, we got a negative value. That means it is acting in the anti-clockwise direction. For MCB, we got a positive value. That means it is acting in the clockwise direction. For MCD, we got a negative value. that means it is acting in the anti-clockwise direction. For MTC also, we got a negative value, that means it is also acting in the anti-clockwise direction. Now we are going to find the reactions. By taking moment about B, we can find HA. By applying the rule sigma H is equal to 0, we can find HB. Then by taking moment about C, we can find VB. Then by applying the rule sigma V is equal to 0, we can find VC. By taking moment about D, we can find HC. By applying the rule sigma H is equal to 0, we can find HD. Using the reactions and loads, we can make the shear force diagram. Using the formulas, we can make the free movement diagram. Using the direction of the end movements, we can make the end movement diagram. Then we can combine the free movement diagram and end movement diagram so that we will get the bending moment diagram. Now we are going to end this session. Thank you for watching this video.